Welcome to the Foojay Podcast, where we celebrate Java's 30th anniversary this May.
Welcome to the Foojay Podcast, all your news about OpenJDK.
In the previous podcast, we celebrated 5 years of Foojay. In this episode, we have another celebration, as we approach May 23rd, marking exactly 30 years since Java's first beta release in 1995. We're honored to present our first ever single guest podcast. But we have a very special guest for you, James Gosling, the creator of Java. Join us for this exclusive conversation as we explore Java's beginnings, its revolutionary impact on the programming world, the continuous evolution over 3 decades, and James' insights on where the language is heading. From that groundbreaking beta release, over write once, run anywhere, to powering billions of devices worldwide. This is the story of Java, told by the man who started it all, the father of Java. Thanks for joining this recording. Thanks for your time. Thanks for starting Java 30 years ago. How is life going nowadays for you?
More like 35 years ago, but...
maybe if we jump back 35 years ago, why and how did you start this?
It started in late 90, early 91. A bunch of us were, noticing computing showing up in all kinds of different places. It wasn't just sort of data center-y things, scientist work desks, that kind of stuff. And it felt like digital systems were expanding. And, we were pretty tuned into that back then, but it felt like the business wasn't paying attention. That Sun wasn't paying attention. So Scott said, okay, grumpy people, go off and investigate this for a while. And so we did. And, one of the things that we did was we went and we talked to people in all kinds of industries who were using, computers and the stuff that they were building. And, everything from people building VCRs to elevators and locomotives. And we did a lot of touring around. I mean, it was quite a fun bunch of months just going and visiting people all over the place, people in Europe, people in Asia, who were building things. And, lots of things came up. Some of it was really frustrating. So like a theme with most of these folks was they were putting networking in everything, but they were reinventing networking. They were doing the kind of invention that computer science had done, a couple decades before and knew why they would fail. So they were doing a lot of things with serial lines. They didn't have as much error correction as they needed. People doing these industrial automation things with 8-bit addresses. It's like, no, 8-bit addresses do not scale. 16 bits is still not enough. And yet, there were stuff that we were learning from them in requirement stocks that we saw with folks. They would never talk about like safety and reliability, not because they didn't care about safety and reliability, but because safety and reliability were such a big deal that there was no point putting it on a list because it was like saying, oh, well, let's build a house and we've got to remember to put oxygen in it. It's just like the unspoken requirement that is deeply not optional. And at the time, performance was everything in computer design. And it was pretty common for people to shave off a little reliability if they could get a little performance. My favorite example of that era was the way that they did division was they used a Newton's method solver rather than the long division you were taught in high school, or at least the electronic version of that. So their division worked really, really fast. But, the low order bits were kind of sketchy. People were doing this all the time. And, even at Sun, people would make trade-offs that made, a bunch of us a little uncomfortable. For a lot of these folks, lives were on the line, right? If you're building the control system for a locomotive or an elevator, when things go wrong, that you usually end up with blood somewhere. Rule number 1 is don't kill your customer. Right.
Well, pretty important rule, yes.
Yeah.
But I find it amazing that you're talking about locomotives and toasters, and people who are using Java nowadays, for them it's a server language, something you deploy on big servers and runs in clouds. And that's the whole difference.
Both directions are true at the same time. There was a whole lot more money in the enterprise world, and so that's kind of where Sun dumped its investment, and things kind of went a little squirrely. But nonetheless, when you look at a lot of the things that people are using web services for, if it's anything from airline scheduling to scheduling a car to pick you up to running a mass transit system, it's like, we had been thinking of devices like elevators, and other people were thinking of devices like the London Underground. The scale is different, but the consequences of failure were pretty much the same, if not larger. And so when things go sideways, they go badly sideways. One of my frustrations with C had been how easy it was to make mistakes that were hard to fix and would have strange consequences that were hard to diagnose. So many corner cases. When we started doing this project, we had sort of surveyed the landscape of things that people were doing and came to understand, what people were doing. And we started building some prototypes just because we're engineers and we do prototypes better than white papers.
Oh, yeah.
One of the nice things about prototypes is that they kind of force you to, mentally visualize the details. We had a few software engineers, a few hardware engineers. We had a really good business guide. As we kept thinking about the kind of requirements list that were coming from these people that we were talking to, a bunch of just sort of standard practice in the software engineering world just kept causing problems. And the biggest ones were the ones around reliability and security. Reliability and security are kind of the same thing. Or they're often related because, so many of the world's security attacks are just bugs. I mean, sometimes they're just they're gross stupidities, but is leaving the root password blank a bug or a sign of gross incompetence? Pick your poison. We started using C, and then it's like, you started using C++, and then it's like, these all have problems. And then, so so I ended up being the guy in the project that was like, okay, let's try to fix some of the methodology problems. Those methodology problems, kept leading me further astray. What started out as being fix some corner cases in C++, became something quite a bit different.
Yeah, it became a complete language, a complete community nowadays.
Yeah,
It's one big, millions of people working and using this Java that you created. How does that feel?
Yeah, no, it feels really great. I mean, the single best feeling I get from it is when somebody comes up to me and says, "Thank you for giving me such a great career." I hardly know how to respond to that because it's wonderful.
Well, I have to thank you myself because you've exactly done the same for me. I've been fiddling with computers since I was 10 with the Commodore 64, that generation. And then found back my programming love when I was already working for some years as a film editor. Because I needed to find a way to get my video on the web. And somehow ended up doing Java. And I tried different languages, but Java was the one that really catched me. I never got my head into doing C and C++. It doesn't fit in my head. I don't know why. But Java is the thing. I can create anything with it. That's the only thing I need is Java, JavaFX, and I can build anything that I want. And it indeed landed me in different jobs, and I could build a career on this. So thank you. Sorry, I have to thank you also for this.
Yeah. Seeing how it spread, and I mean, sometimes it has its downsides. I mean, the whole Y2K thing was kind of terrifying because a lot of people migrated from COBOL to Java because of Y2K, and I am the author of JavaLang Date. I spent a whole maybe a whole week on it. All the fancy calendar classes have come since the year 2000. But, that night I could not sleep, and I was tuned in to every chat channel and to try to see what was going on. Did anything go sideways? And of course we had run all kinds of drills, taking computers, pushing their clock forward, a month or whatever, so that we had been through Y2K many, many times. But the real Y2K was different.
But still, you had these people who were saying afterwards, it was not so bad. They said the world would stop, but it was not so bad. But wasn't it because all those engineers were already trying for years what could happen?
Exactly. I mean, one of the difficulties with being an engineer is that the absolute best case for your job is that nobody notices.
Yeah.
Right. If you do something, if something exciting happens, you have probably failed. Right. If you're the kind of person who lives on, adulation and adrenaline, maybe engineering is not for you. Right. I mean, you have to get your thrills out of a bridge not falling down. Right.
It's like with the problem we had some years ago with Log4j. There was a vulnerability. So suddenly that library becomes a big problem. But on the other side, people put a lot of effort in that library. A lot of people use it and simplified their job. And then suddenly for that one thing which appears, the whole system, it loses its fame. But it's like you said, if you don't do anything, you cannot do anything wrong.
Right.
Are there many things like that within Java? that you think I made a mistake? People will maybe say the null pointer or the null pointer exception. Was that a mistake?
These things, so many of these things, they are a game of, do you know what whack-a-mole is?
Mm-hmm.
This game where you're hitting moles that pop up, and engineering is like that. And there are always trade-offs. And, the trade-offs we're best at dealing with are engineering ones, but sometimes the sociology ones are more difficult.
Mm-hmm.
So one of the things I get hit up for a lot was generics. There was a big fight in '94 about generics, that there was people who were like, gotta have generics.
Mm-hmm.
And I was like, okay, because these were people who were like using it, and they had come from the C++ world. But C++'s generics were fucked. We got to do it right. And then the question is, so what's right?
Mm-hmm.
I talked to lots of people. I mean, generics in programming languages were like a big area of research. And there was no consistent view on what would be good.
Mm-hmm.
There was a contingent that said, we should just not ship anything until we've got this generics thing. And it was pretty clear that it would cost us 2 or 3 years.
Yeah.
If we had delayed 2 or 3 years, the internet was exploding, right? I mean, it was in the really early stages of exploding. If we had waited a couple of years to get it right, we would have missed it.
Mm-hmm.
If I just like slapped something in and it was wrong,
Yeah.
which I figured there was like a 99% chance that undoing it would be difficult. There were lots of object-oriented programming languages that didn't have generics, and they worked just fine.
Mm-hmm.
And then eventually, there was this almost global competition for, how should Java generics be done? Mm-hmm. One of the big questions was, how it interacted with introspection. Nobody came up with a solution that worked. It's a debate about what's called reification. We could have made reification work if we had broken every app in existence.
Which totally breaks with the Java philosophy, I think.
Yeah, and when you've got a big community of users, you end up with a big responsibility to not screw them over. I hear from friends today even about, that was a mistake. And it's like, no, it wasn't a mistake. It was a compromise.
Mm-hmm. Is there a big difference between how you, as the founder of Java and the original creator, how you could work at those days and how the evolution of Java now goes with the JEPs and the 6-month release cycle? Is it a complete different approach? I guess.
Oh, it's completely different. It's completely different. Until the launch, I could make sweeping changes in an afternoon. And no harm, no foul, easy. Mm-hmm. And I often did. There was the day I eliminated GoTo because I had finally had too much of how stupid it was. I mean, I sort of by default decided to inherit a lot of what C and C++ did so that they would be familiar with people. But GoTo is one of these things that causes all kinds of weird corner cases. And one afternoon, I literally just got frustrated, did some limited studies, and went, boom, it's gone. That was a tremendously luxurious time. Mm-hmm. There's this really annoying engineering principle that gets used in Silicon Valley a lot that I have deeply mixed feelings about it. And you hear it, from people like Elon Musk and Mark Zuckerberg, right? Move fast and break things, right? And I'm all for that when you're building a prototype. But once you've got people that are using it and that depend on it and all of that, oh man, the game changes completely. I'm okay with the move fast thing,
But not the breaking.
but not breaking. And often move fast is interpreted as just do arbitrarily stupid things to see, how people bitch about it. That is not a good customer experience.
Yeah. And that's what a lot of people are surprised about, that you can have very old Java applications still running on the newest runtimes, which is exactly one of the strong points of the whole Java system.
Yeah, a long time ago, for a demo at something, I wrote a Swing app to play solitaire. I still have that binary. It was written for like Java 7 or 6 or something. And I still run it, actually embarrassingly often, because it is solitaire, right? Which is sort of
the game to play, yeah.
The brain-sucking magnet. But the thing is that that binary was compiled like 20 years ago, and it still works great. I've played it on my brand spanking new Mac Studio, on architectures and OSs that did not exist at the time that the program was built. It runs great. Actually, it runs astonishingly well. I mean, all the graphic animations are just as smooth as could be.
But that's the whole write once, run anywhere philosophy that was there from the beginning. Do you think that it still stands?
It stands really well. Yeah, I mean, it's not perfect, but it's really pretty close. And, one of the things that I really like about it is that I don't have to compile stuff over and over and over again. I don't have to generate 20 or 30 binaries of things for all the different flavors of devices that are out there. My solitaire program, the binary that runs on Linux is the binary that runs on macOS. And I just have one binary.
Yeah.
That's really nice. I mean, there are often, places where things leak through. So like if you're doing shell scripts or something, then ouch. But it's not like Java is any worse than any of the other platforms. And really the only really painful outlier is Windows.
Yeah. And how did that happen?
Because Windows is unlike the others. I mean, most systems except Windows went down sort of the Unix path, and even Windows now has their Linux subsystem, which they kind of had to do because using Windows in the cloud is really expensive.
I'm a big fan of the Raspberry Pis. There are a bunch of them behind me. And
oh yeah,
that's
I
one.
Raspberry Pi. This is a Jetson Nano.
Yeah.
An old Jetson Nano.
And also all these amazing cheap boards are perfect machines to experiment with Java and run any kind of Java. I have JavaFX applications which are very heavy with animations which just run on those platforms.
Yeah, no, it's really great. I mean, the people JavaFX is one of my favorite things of all time. Man, that crew has done such great work, even after Oracle basically disowned them.
Do you think
Yeah.
that JavaFX would have a bigger market share if it would get
I
some more love from Oracle, for instance?
I sure had hopes. The world of desktop apps has become really fragmented. I find it fascinating that there are basically two, for mobile devices, there are two foundational platforms, Android and iPhone, and they work just as hard as they can to be different. They really like their own distinctiveness, which I can totally relate to why those two camps want to do that. But wearing my, developer hat, that just sucks. And, even though Android started out as kind of a Java thing, the way that they completely broke all of the graphics and UI APIs was just, ugh. I should shut up about Android because it just,
And we had the Java phone one day.
yeah.
It never launched, I think, but could we have Android, iOS, Java phones?
Sure. Sure.
Or would they even be
Sure.
better than the
Sure,
others?
Java runs great on iPhones. The problem is that from the very beginning, the iPhone terms of service don't allow the use of Java for deployment. So people have the people who really want to do Java apps, and this is one of the places where the JavaFX folks really really went to town. Is that there are essentially static cross compilers that compile from the Java universe into the iPhone toolchain, and then you can get things published. You can get Java applications published on the iPhone store, but you have to go through the crazy toolchain jumping around.
Which is indeed crazy. I have done too many failed experiments on that matter. What do we need to make Java the platform for mobile and embedded development?
I think as developers, there's nothing we can do.
No.
It would take, the Android universe and the iPhone universe to start thinking about the universe completely differently. And that doesn't feel terrifically likely to me.
There are too big companies to compete.
Yeah. The write once, run anywhere thing, it sort of grew out of, Sun, who was a kind of a minor player in the computer market, particularly early on. Trying to get people to develop software for Sun was really difficult, because they'd go, well, you have this percentage of the market, but these other guys over here have that percentage of the market. And yeah, it sucks to write software for that, but the engineers don't get to decide this, right? The business people who go, yeah, but we'll make 5 times more money or 10 times more money if we can sell on that platform. When you do something like Java, you can get all the small players together, and then the small players and the big players can get together. Now that we're in a universe where all the players have kind of collapsed, there isn't nearly as much diversity in the hardware ecosystem as there used to be. If you're buying a laptop, there's only 2 choices, really. There's kind of a third, but it's only kind of a third. I mean, for people like you and me, a Linux laptop is a viable choice. But for 99% of the public, it's not.
Which which is a bit strange because it runs smoother on smaller and cheaper computers.
Absolutely.
So that's something I don't understand, why schools are all hooked on Chromebooks and Windows PCs, while there are so better alternatives. But yeah, I think it's just marketing. They are so better in marketing.
Well, it's marketing, and it's kind of what you know.
Mm-hmm.
I mean, I keep being frustrated with corporations that insist on using Windows for everything.
Mm-hmm.
More because it's what they know. You know, Windows has this long history of horrible security issues. They're getting better, but they're still the worst. It's still the least secure platform on the planet. And Linux is probably the most secure, followed pretty closely by macOS and or iOS. They're kind of the same thing in my mind. You know, Apple has the advantage that they can fix a security flaw and have it deployed everywhere around the planet in like days, whereas the Windows folks have a much harder time.
Another question, as if we go back to Linux, did you ever expect that the whole cloud system, which didn't exist when you started Java thing, that would run on Java for a big part?
No.
Was that a goal, to have a server-side language?
Believe it or not, the first Java app server was written in 1994. All of the Java EE core APIs were actually, a bunch of them were actually from 94. That's when Class Servlet came out. Yeah, so one of the unappreciated facts is that I'm the person who wrote the original Class Servlet. At the time, it was just like me kind of goofing around going, hey, this works really, really well. Then the story gets kind of dark because I basically got told to throw that stuff in the trash because Sun had some partners that wouldn't view the competition really happily. And in retrospect, I'm sure that was a violation of the Sherman Antitrust Act. But
yeah, it was, I think no one could predict how all these things would evolve.
Right.
People say Java is not meant to run in Docker. Yeah, Docker didn't exist. That ID didn't exist, I guess, when you started working on Java.
And yet people have figured out how to make things run in Java to run in Docker containers really well. And it's not like Java is the only thing that has trouble with Docker containers. I mean, the one end, the major issue with Docker containers with Java is startup time. And Docker itself has horrible startup time problems. If only because it wants to boot up Linux. And the things that they do to make Linux boot fast are pretty much exactly the same sort of things that you need to do to make Java start up fast. But, again, this is one of these sort of engineering compromise questions where, back in the day when we were starting to do server things for real, the general model was you boot up a server and it just runs for a long time. And so you push everything into optimizing for high performance over the long haul. A lot of the things that you want to do to get that kind of performance really good fights against startup time.
Yeah.
And there are lots of places where, getting startup time or consistent timing fight with throughput. Simple things like hash tables, right? Everybody thinks of a hash table as something that's really, really fast. And if you're fetching something out of a hash table, it is really, really fast. If you're storing something, a hash table is really, really fast, mostly, right? Every now and then, the hash table gets gummed up and you have to do some sort of restructuring of the hash table. And, there's a huge laundry list of variations on hash tables. But at the end of the day, they all have the sort of timing anomalies, that you just have to do something in order to optimize performance. And almost all systems have, sort of algorithmic cheats that give you high performance, but every now and then there's something you have to do to make that work. And if you look at Hotspot at all, it is an astonishing piece of engineering. The stuff that it does is mind-blowing. And these days, it's between the code generators, I find still astonishing that they're actually beating benchmarks against LLVM. The garbage collectors are just crazy good.
Well, that was one of the amazing... When I started working for Azul, one of my very first things I had to do was write a blog post about the different garbage collectors. And I have been doing Java development for over 10 years. And I never bothered about the garbage collector because it just did what it had to do. And then by writing that blog post and talking to people who developed those different types of garbage collectors, I realized, but there's so much in this. There's so much knowledge. There's so much technology to make sure that you as a developer just don't need to care.
Yeah,
and that's the amazing thing.
Garbage collectors are amazing in so many ways. I mean, they make so much complexity go away. They allow so much complexity, so like people have been falling in love with Rust for storage management. And I like Rust for storage management. The problem is that as soon as your data structures get complicated, the Rust techniques start failing. And if you've got like really complex data structures with all kinds of cross linkings and caches that do this and that, and oh man, the Java garbage collector just makes the right stuff happen. And it does it really quickly. I mean, but I talk to people these days who still have this notion that garbage collectors are slow.
Yeah.
That it takes minutes to do a garbage collection. And I'm sorry, it hasn't taken minutes to do a garbage collection for decades.
Yeah. People who are not a fan of Java, most of the times they have been doing Java a long time ago.
Yeah.
And they didn't follow up on what has happened, what the community has contributed, what all these improvements have brought in all these versions.
Yeah. I mean, these days, a half-decent garbage collector will give you guaranteed maximum pause times of well under a second. And the really good ones, will give you maximum pause times in like 5 to 10 milliseconds. And of course, one of the reasons that there are more than one garbage collector in the world is that there's this trade-off between throughput and latency, right? If you want to have less overhead, you've got to accept more sort of bumpiness in timing. I mean, it's exactly the hash table example that I just went through, right? If you want it to go really, really fast, you have to accept the fact that every now and then there needs to be some data structure reorganization. You can fight it. You can do all kinds of algorithmic tricks, but all you're doing is smooshing the statistics. You're not getting rid of all the lumpiness. But then there are the ones where the lumpiness goes completely away, but a cost in that is throughput. 20 years ago, 25 years ago, to get consistent throughput, or sort of low latency, the overhead was in the like 30% in terms of throughput. But these days, the throughput overheads to get guaranteed really tiny latencies is in like 1-2% kind of thing, kind of space. Garbage collection is like the single most invisible technology there is in this universe. And yet you start reading the papers on garbage collection, and my God, it's an exotic world.
And it's amazing that they improved so much, although, on the other hand, the systems became so much bigger, much more memory that's used. On the other hand, we also have more CPUs below it. So, yeah, it's amazing how much all these things evolved. Eh?
That's kind of one of the places where Java has kind of fallen from truth when it comes to like running on embedded systems. In the sort of server world, nothing has a gigabyte of RAM. Raspberry Pis typically have 8 to 16 gigabytes of RAM if you buy a new one. My new desktop computer that's sitting right in front of me has 256 gigabytes of RAM, and for Christ's sake, that's a lot of RAM. And of course, the reason for all that RAM is that there are tricks you can do to make things faster. If you want to fit into small amounts of RAM, there's things you just can't do because you don't have the space for it. And at the same time, certain kinds of engineering sloppiness can be covered over by lots of RAM. In a project that I did several years ago, one of the things that just annoyed the hell out of me is that it was consuming a lot of RAM, and going into it, so it's like, oh, the Java VM is really soaking up lots of RAM, and it's like, well, turns out no, the Java VM doesn't show up much RAM. It's like all the libraries that you suck in. And one of the delights of the Java ecosystem is that there's such a selection of everything, but it's also one of the biggest pains.
Oh yeah,
because one of my favorite things to hate is HTTP. And in this one app that we went through and did a lot of analysis on, there were like 5 complete HTTP stacks, right? I mean, there's the HTTP stack that comes with the JVM, the AWS library, for reasons that I don't understand, decided they needed to have their own special custom HTTP stack. The Google folks, because if you touch any Google library, you get kind of the transitive closure of the Google universe sucked in. And so you end up with the Google HTTP stack. And then there's, and then you start using any Apache library, and Apache has their own HTTP stack. It's easier for, one of these organizations to just make their own HTTP stack than it is to start negotiating with other people to make sure that there's one HTTP stack that makes everybody happy. And we could easily have done that, but it's move fast and break things.
Yeah. It's also responsibility of the developer. I've been in projects where we had three different XML libraries.
Oh yeah, that's easy, or JSON libraries. I mean, one of the saving graces in the JSON universe is that the Jackson libraries won early and they won really soundly. Except, of course, that there are two Jackson libraries, Jackson and Jackson Jr. And Jackson is way larger, but it's also much faster. And, for good reasons. But it also has a bunch more features than Jackson Jr., right? So in that same project where we had like all these HTTP stacks, we also had both versions of Jackson because some of the I tend to be fairly meticulous about only using Jackson Jr. But lots of other folks, they really like the Jackson features. So then you start, and I like the Jackson features too. I'm just a crotchety penny pincher when it comes to bytes. I mean, I tend to count bytes of RAM one at a time. But you watch these things go and of course, JSON is one of these things where, at least for a JSON writer, you don't need anything more than printf. Yeah. I actually kind of like that style of generating JSON, which I know many of my compatriots find rather disturbing.
You briefly mentioned Rust as a competitor, but how do you feel about the languages which were created on top of the JVM? Because we're now talking the whole time about Java as the language, but actually it's the language and the runtime. Right. And then you have Kotlin, Scala, Clojure, which were all created on top of that same virtual machine. How do you think about
I think those
this
are
evolution?
Cool. I like all of those. Scala was a really early success story that I quite liked. But I guess I never found it compelling enough to sort of drop what I was doing. I mean, I'm not somebody who follows trendy styles pretty quickly. I mean, I'm a t-shirt and jeans guy. Clojure's pretty cool. I think for cool points, I like Clojure a lot. The problem with Clojure is that it's really different than the way that most people think. I mean, it's this, Lisp syntax with really strict functional approach to life. And I'm a big fan of functional programming, but there are places where a functional style works great and places where it doesn't. And I tend to write Java code in a functional style, which is another thing I do that drives other engineers completely batshit crazy. I would much rather use recursion than an array, but that's just me.
A completely different topic. I saw on one of your messages on LinkedIn that you also ask people to think about their job and the responsibility of their job If you're working as a programmer in a company and you get asked to do something which you can consider as evil, strange marketing tricks and stuff like that, how responsible are we as developers of how we are using our tools, our developer power?
If your corporate leadership asks you to do something unethical, I'm a strong believer that you just walk away. I mean, start with having a discussion with them about, do you really want to do that? Do you really understand the consequences of that? And occasionally you might get them going, oh, you're right. We shouldn't be fucking over our customers. We didn't really think about the long-term consequences of that. But more often what you get is, oh yeah, that's fine. And you meet people who have worked for like health insurance companies, and you just get these stories that it's like, they do what? That sort of rubs up against reality, because if you're in a period where jobs are easy to find, which has been pretty common for software engineers,
Which was the case, yes.
then just walking out on the job is easy. But right now, the job market is really, really different, particularly in the U.S. I mean, the U.S. is just so screwed right now. One of my LinkedIn posts was on the concept of fuck you money. This has been around for centuries, right? It's like, do you have enough money saved so that you can just say fuck you to your employer and just walk out? Because if you don't have fuck you money, you're basically a slave. Slavery comes in other forms too, right? So if you're a parent and you have a child that's got serious medical issues, given the way that the American healthcare system works, if you leave your employer, you're potentially impacting the health of your child. That's one of the advantages from an employer's point of view of the totally fucked up American healthcare system, right? Is that it makes employees dependent on their employer in a way that's, maybe not technically slavery, but it can feel pretty close to that.
I have to admit, I live in Belgium, the European Union, it feels so strange to see how things on the other side of the ocean work.
I'm Canadian, right? So I grew up with a similar sort of thing, and when I went to grad school eons ago, I was completely clueless about the bizarreness of the American healthcare system, and I came down with an illness. Ended up having to go to the emergency room, and I had no clue that this was going to reduce me to absolute poverty. And I mean, it completely drained every penny I had. I mean, it was horrible. It just turns into a nightmare. And so if you're an engineer and you're trying to live an ethical life, which I would like to think most people are, you end up with these really, really, really hard choices.
Will choices not become even harder with the whole competition we have from AI? For a lot of directors, engineers, for a lot of bosses, they think that they won't need any more software developers.
And I think they're kidding themselves.
Absolutely.
And I think some of it I find almost comical. That a bunch of the AI folks have been saying, the open AIs of the world have been saying, you don't need copywriters and you don't need this is and that is and those is, because AI can do it all. AI can do some of it. So far, the results are like really bad. Classic examples like the law firm that thought that they could just use AI to write legal briefs, and the legal briefs sounded pretty good, except that they were complete hooey, and they got sanctioned and did it. But for software engineering, I think it's a really different thing, because there's this interesting thing about software engineering as a career, which is that, we have libraries, right? If you do something over and over again, normally you put it in a library somewhere. And if you've got something that lots of people use, it ends up as an open source library. It's really uncommon for software engineers, except when they're learning, to do something that somebody else has already done. It might be kind of like what somebody else has already done. But if it really is what somebody else has already done, you can probably just find a library out there that already implements it. And so, the way that all these Gen AI systems work is that they end up, in their heart, they're trained on gobs of code that's out there. And they can fill in, based on stuff that's out there. They're really good at kind of interpolation, but interpolation is not the easy part of software engineering, right? And most software engineering is about extrapolation. And, so like if you're a civil engineer and you're building bridges, once you've built one bridge, you have to do engineering again for the next bridge and engineering again for the next bridge. In software engineering, you have to do all this complex engineering for the first bridge. But then copying a piece of software engineering and making like the next bridge and the next bridge, that's free. Mm-hmm. And one of my favorite things about software engineering is that more often than not, you're doing things that nobody has done before. And maybe when you're a student, you're always doing things that people have been done before. The usages I've seen for things like ChatGPT have mostly been in like learning stuff. I've found myself using it as kind of an automated help system. Mm-hmm. It's like, how do I write a piece of code to connect this to that? It's got some probability of being accurate. Mm-hmm.
Or the way forward.
Yeah, so it's like a really sophisticated grep over all the source code in the universe. Mm-hmm. But that's really, really different than writing truly new code.
Mm-hmm. And what people forget, the main task for the developer is finding out what the exact problem is that needs to be solved. So you first need to go through that process of, people ask me to do something, but why do I need to do it? What is the exact problem that I need to fix? So you need to understand the problem before you can implement it. And that's not something which I think a chat system will do very fast.
Yeah. I mean, if you're given clear instructions for what to do, yeah, maybe. Mm-hmm. But you're never given clear instructions. Sometimes you are given clear instructions, and in my experience, the clearer the instructions are, the more likely they are to be just completely wrong. Usually if you're a manager, your skill set is about dealing with people. Most people who are good engineers are not really good people. Mm-hmm. And so sometimes you get managers who think they know what they're doing when it comes to engineering, and occasionally they do. Mm-hmm. but mostly they've just got an ego problem. And they're telling you how to do your job. And in truth, they're just full of it. Mm-hmm. There are very few things as painful as a bad manager.
Mm-hmm. What advice would you give to junior programmers if they're dealing with bad managers, if they have to choose a language? Do you have some good advices for starters?
Things are always easier when you enjoy them. And I've always found that I do a lot better if I'm, working on projects that I find just really fascinating. And one of the nice things about software engineering is that, software is a tool. And it's used in a lot of different industries. So I tend to pick jobs more about the environment that they're picked in, that they're embedded in. I'm kind of like a space nerd. I really enjoy sailing and boats and things, and I've had the good luck to have some jobs that let me sort of bump up against a lot of those things when I've, had the luxury of being able to, actually pick a job. I'm not good enough at math to be a physicist, but I can work for a physicist and have a really good time. If you're lucky enough and you can find environments where that sort of thing works for you. When you've got tight job markets like right now, it's kind of beggars can't be choosers. Mm-hmm. And then, it can often just be suck it up, do what you need to do.
And wait for a better time.
Yeah, wait for a better time.
If you look back at 30, 35 years when you started Java, can you point out a few of the significant moments? Probably a lot of them, but can you pick a few of them?
Well, I mean, they're all the obvious ones, like launching it, the kind of crazy relationship with Netscape, bizarre relationships with the rest of the industry. One of the things we were getting criticized for was not going open source earlier. Mm-hmm. We were actually distributing the source from the very beginning, but we weren't using a license that, the open source priesthood really liked. And, there are a variety of issues there, but, from our point of view, the big issue was, man, there are some big competitors who want nothing more than to crush us. Mm-hmm. A truly open source license would have given them a license to kill. Mm-hmm. And, there were half a dozen such companies that we worried about. And, then you end up with this place where that things would be better if you were in an open source license, except that you would be dead. Mm-hmm. That was not pretty. Mm-hmm. For points that had drama, it's kind of hard to beat some of the standards committee meetings. Standards committee meetings they tend to be about the most boring things you can imagine. But, we had been doing these negotiations with ECMA for Java to become an ECMA standard. Mm-hmm. And what we didn't know was that 3 large corporations that will remain anonymous, but you can probably guess who they were, had been working with ECMA in the background So we had this agreement with ECMA for what it would look like. And we had this one meeting where we were going to finalize it all. Mm-hmm. And the ECMA representative, who we had dinner with the night before and was all on board with what we wanted to do, announced that the plan was that Java would be split into 3 pieces: the language, the virtual machine, and the libraries. And each of these 3 companies would take the lead on those. And Sun had no role in anything. Each of those 3 companies could do whatever they wanted without consulting anyone.
What a bad idea.
An idiotic idea, right? So we walked out, and then, all these other people were like, Sun, they're such assholes, they don't want to standardize it. And it's like, you guys don't actually know what happened in the room, right? And, oh man, fortunately I was in the room, but I hadn't been deeply involved in all the negotiations with the standards committees. And, we had tried variations of this with some other standards organizations, and they all went the same way. And the one with ECMA was like the last one. And we just felt so completely screwed over. I don't know how it got so weird. But
I think you already mentioned it. Egos at some point, some people pushing their ideas.
It's competition, right? It's money, it's control, it's, some of it is ego, but, when it comes to corporate stuff, ego isn't as big a deal as greed.
The money.
Pretty much greed conquers all, and it's sad.
But I'm happy that didn't happen, splitting that thing into 3 pieces, because now I have one clean, consistent Java JVM ecosystem around it.
And all these, and the thing about stuff like this is that they're ecosystems. All the pieces influence all the other pieces. One of the things that really worked well for Java over the years, because one of the questions I keep getting asked is, so why didn't you become benevolent dictator for life? And besides the fact that would have completely screwed over my life and I would never get to do anything else again in my life, it really mattered to me that all the different people who were writing software in Java, they had concerns. And I really wanted their voices to be heard. Because the only way you can build something that people want to use is to listen to what they want and give their expression of their wants some legitimacy, right? And that's how you end up with something like the Java community process, right? Which ends up, it on the one hand, it's a little annoying because you end up with these rooms with people sort of duking it out. On the other hand, and it can get slow and messy, but on the other hand, the voices come out. It's kind of like that line about democracy. Democracy is the worst form of government ever, except for all the others.
And is that how Java works nowadays? Is there a good system? Will it evolve in the right direction in the next 30 years?
I've been surprised at how well it's been working.
Were you surprised with how well the 6-month release cycle worked?
I actually don't think that the 6-month release cycle changed anything. Because before the 6-month release cycle, when it was kind of like a 3-year release cycle, during that 3 years, there were builds always being posted. and a lot of people were using these intermediate builds, and I was certainly using them a lot. The intermediate builds were usually pretty damn solid.
Just like 24, 23, the ones in between the long-term support versions we have now.
Right. So now, yes, okay. So there's a release every 6 months, but there's a long-term release every 2 or 3 years?
Now 2 years, yeah.
Yeah. So
it's a bit the same, but in a different form.
Yes. So it basically is the same thing, but at least the current release cycle,
it's very predictable.
It's more predictable. The one thing that I'm kind of annoyed about with it is that there are all these preview features, and sometimes things stay in preview for a really long time, right? And so before the 6 month cycle, the way it used to work was big, complicated new features could only be proposed at the beginning of the cycle. And then there would be all these little releases that people could experiment with. But the next time there was, the 2 or 3 year release, it was solid. There was no preview anything. And
It's finished, yeah.
So now I find myself using all these preview features, which on the one hand is great because most of the interesting stuff is a preview feature. But you never really, the fact that they allow things in long-term releases to still be in preview kind of sucks. Mostly, when things are in preview, they converge pretty quickly, but some things kind of explode. And, certainly the double quote thing, which I found myself falling in love with and using in perhaps slightly odd ways. And then that just got completely blown up. And then it's like, oh, God, now I can't use the latest VM. I can't use the latest version of Java unless I go and do some major changes, which, it's like, okay, Brian's got a point. He usually does.
Are you still involved in the discussions?
Sometimes.
Are you officially retired?
I am officially retired. I am unemployed. I listen to no higher master than my wife.
And how big of a master is Java still for you?
Not much, really. I've been, out of the Java organization for 15 years now. And, the people who are looking after it right now, I highly respect them. They're really good. And the community keeps them in line. So that's lovely. And I'm a person that's not someone who likes to go around yelling and screaming at people.
Any last message you have for the Java community to close this interview?
Have fun. Keep building.
And keep building is what we will do. Thanks, James, for the great talk and for creating Java and the GVM. Thank you for listening. Please subscribe to the Foojay Podcast in your favorite app or on YouTube. Keep an eye on Foojay for future articles and podcasts about development and everything related to the Java world. See you next time.
Give me a foo, give me a J, give me the friends of OpenJDK.